Hello. A bit later than I planned. But my aim for today is I want to basically do this side of the board. I'll show you the I'm going to make this basically this part of the board cleaner. I'm just going to be working on the layout, and then the next day, Friday, hopefully I'm going to be doing the connectors. Something I forgot to do. Sorry, turn that off. Something I forgot to do was ERC check, which is a good way to make sure your schematic is right. It will have loads of errors because it... Oh! What am I doing? Where's this one? I need to put in power flags to let the ERC checker know that something's a power supply. Oh, where's these funny power? I might do that. I might actually just hide that for cleanness. See here, it's saying it thinks this is a power output, or actually it thinks this is a power input, but it's not. It's a USB host port. So we'll just put the power flag there to say that's power coming in. Any more of those errors? 3.3 volt A. Interestingly, where's that coming from? That's coming from its own dedicated... Oh yeah, it's over here. I don't know, why is that... Why am I powering that one by 5 volts? Oh, I thought that was a B. It recommended that you supply the analog supply voltage with 5 volts. Aha, that's why I did it. And the digital side, which is where? VDD. Oh yeah, there it is. Okay. sorry, and then the PCM 5102. Good to double check these things. I went over these ages ago. Where's the supply voltage? It's 3.3. So it's different on the DAC than it is the ADC. Now back to where is 3.3 volt A coming from? Find it by looking at the regulators. That one. There isn't a 3.3 volt A. Hilarious. Maybe this is copied from another design. Question is should I put in another regulator? Yeah. Why not? Or do I just nick it from here? Yeah, let's just from there. Screw it. Let's just do that for now. Just want to find the power ones. Unspecified. Okay, it looks like all the power pins are sorted. Symbol off end of connection grid. What? Huh? Oh. Probably that weird thing coming from a different version of KiCad. There was a weird thing with KiCad 7, I think it was, that had a strange grid. There was some bug with the grids. This doesn't connect to anything. Gate 2 out micro. It should go to here. Ah, but it doesn't. Oh, Luke Vosper's asking what I'm making. It's, I should really reintroduce it every single time. It's sort of like a... Oh, I know. It's a module, a programmable module, a general purpose one based around the 2350. The new Raspberry Pi Pico chip. I used this quite neat display, quite high resolution. It's just sort of almost like a prototyping platform. But my idea is that you can get the whole thing completely assembled at JLC PCB, including the jacks and everything. So it's kind of like a DIY no solder kit. That's what I'm making. Anyway, I'll go back. I've just realised I'm missing the gates coming out. So I had audio in 1, 2, CV in 1, 2, gate in 1, 3, 4, gate in 1, 2, CV 1, 2, 3, 4, audio out 1, 2. Oh dear. I think I probably ran out of pins. Ah, there's ground A, we don't need that. Definitely don't need that. There we go. Maybe I'll move this stuff down. Yeah, this is a Luke Vosper's asking. It's a big connector. This is a ribbon cable. I'm not using headers. I'm using a. It's easier in a 3D viewer. I'm using a ribbon cable that's going to come from the main sort of brain board, come out through the back here and into the connector board. Just saves a lot of soldering and space. Basically, it's a technique I've been trying to develop. I've used it in other boards. It's a FPC connector and it's like 0.1mm pitch, I think. But I'm trying to stick to standard. The 40 pin version, because that's like the most common FPC connector you can buy. Ribbon cable. And if anyone's new to this, it's confusing because I've sort of gone a bit off-piste in terms of like in KiCad, general practice is to make a new board separately. So you'd make boards separately and then sort of make a panel of them later, but in this instance I wanted to make them all as one, so I have separate nets for each board. I mean, the most complicated is going to be this big one here. And then most of this is just connector board. So I've done this weird thing where I have the giant connector, two connectors. This represents the connector on the the brain board, and the one on the right is the connector on the jack board. And I've arranged them so they look like they're connected to each other, but they're actually going via this connector. I don't know if it's the best idea in terms of legibility, but it makes everything sort of in one project, which was the idea. Just makes it more trackable if it's in one project, all stacked together. But that was lucky. I almost ran out of space then, but I've managed to fit these gates in. Which the ERC checker has told me, which is something that's quite easy to not use. It tells you when things are not connected to each other. So like, what have I done here? This one is not. See, these aren't in CV in 1 micro. Oh, it's because I changed their names. It's called CV Gate 1, and because these are special purpose. No, wait, that's not CV Gate. CV in 1 micro. CV in 2 micro. And it's this one that's called CV Gate because it's either a CV into an ADC or a gate in, which seems a bit odd because like, why would you do that? But it's because it's scaled to fit to an ADC, and it's quite nice to just use it as a standard I/O. So that just uses a comparator. That should have fixed it. No, it didn't. Yes, it did. But then there's switches. Oh yeah, it's called switch run. Switch run micro, switch user 1 micro, user 2 micro. Oh, and there's a new switch as well. Oh. It's because it's because I relabeled them. But I didn't really, I just made them easier to understand. This one's called Switch Run Micro. Which should be... Oh, I just called it Run. Oh, I just called it... No. Just messed up a bit of the naming of labels. Right, we're getting through our errors. This is the USB. I've definitely called that something. The USB host. I've probably just no, I haven't. That's on the jack. The USB host is... Where is the USB host? Oh no! Oh, did the USB host power? But where's the USB host? No! I need more IOs. I need 2 more IOs. Well, switch, run. Oh, on the jack side. That should be here. Yeah. No. They're not connected. Huh? Oh, these shouldn't be 3.3 anyway. They should be the... Oh no, they should. Ah, should be that. I seem to have an odd... Oh, maybe they've swapped. The symbol seems to have changed at some point. Must have copied it from somewhere else. boring stuff. There's more here. It seems to have changed from 3.3, 3v3 to... I like saying 3v3, but apparently now they think you should do 3.3. Undoubtedly more. God, there's a lot of errors. Loads of these. I should just do a find and replace, shouldn't I? You go. And you go. Change symbol. Change anything with that to... Here we go. There is a 3v3. What? I'm in the power library and there's something called v3.3. I'll call them... Yeah, I'll just do that. Get rid of the warnings. This is getting boring. That doesn't connect to anything. Gate in 1 and gate in 2. I'm missing loads of stuff. No there. Gate in... MCU gate 1 in. But I've changed it to... Gate in 3, gate in 4. I've changed the naming convention or something. I have. Wait a minute. Is this the thing that I thought I was missing? Or was that gate out? Might have been gate out. I'm missing the host pins. They're not connected, I know. 5 volts should be driven by something. Yeah, it's there. Are these not the same? Power, 5 volts. Strange. Oh, it's because it's connected to an inductor. Just put a power flag on it. Another one. Ground 8. I'm getting... Oh, I'm not doing split grounds. I'm doing ground planes. In fact, there's only more ground A's. I have to do find and replace. Why does it do that? Oh yeah, that comes in on a power supply. So we'll have to say these are both power flags. The only purpose in this part component, power flag, is just to tell the ERC checker that something is a power pin. Oh, and now. Oops. Now we've got another different symbol. We've got about 3 different versions of the same power symbol. Oh yeah, because that's a power. Not another one. Wait, I'm really confused. Got about 5 different versions of the same net. Oh, see, I thought I got rid of that. And there. And there. God, this is taking a lot longer than I thought. Yeah, that's expected. This 1v1. Wait. Isn't that supposed to be connected across? It was just it's connected internally, I think. In the RP2040, it had an output and an input, but seems here that but it's weird that chip should have well, it can't do because they're power inputs. Strange. But we can just put a flag on it. More analog grounds that I'm no longer using. This needs moving. Oh, another bunch of... I thought I replaced them all. I said replace them all, but it doesn't... VREG AVDD. Now what's that again? Is that where our reference goes? No, that's there. VREG AVD. Oh yeah. Just need to put a power flag on it. I might also put one here, even though it's not complaining about it. Still, there's those two. Ah, another analog ground. Right. Just a few more of these boring bits left. I'll flag these. That's coming from there, and that's the ground. Again, this is strange. It's like they're alien connections. Oh, now it's saying that one's. Power pin not provided by any output power. Oh, is it because my ground? Ah, yeah. Put the power flag on the input. So we've got disconnected things that have no place. We have 2 unconnected pins, which we're going to use probably, and we have another analog ground that we're not using anymore. So you look at all those errors that I've picked up just by running at ESC. Now I've got a big problem. I have a USB host port and nowhere for it to go. I know it could go anywhere, but I need to free up 2 pins. I'm thinking of putting in a I2C IO expander. But I'll use a common one that Adafruit might use, for example. Adafruit's always a good place to go for common IO expander, well, common things. So they've got this one. Now compare it to it shouldn't cost. Right, I'll go to yeah, do you think that's a good IO expander? Let's hope it's cheap. I need a cheap one. Because I'm also thinking maybe, I don't know, but I'm out of pins anyway, so what's the point? Might want to add some LED, but I don't know, I'm out of pins everywhere. amount of pins everywhere. I was thinking of expanding the I/O expander out to things that are a little bit slow and doesn't get switched very often. For example, the power enable. I want all the settings for the I2C devices, like this one, because these are just the I/O. Sorry, the sound I2S. What else? That would pretty much, it would only be 3 things. The chip select for the PS RAM is a no. Oh, the mute on the DAC. That doesn't have to be fast. Or native. So that's already 1, 2, 3, 4 things that I can put out to an I/O expander. Chris Johnson, if short of pins, can you share a single USB for both host and device? I don't know, because in the E2350 it's a peripheral for the host, and it's actually, no, it's the main way that you can load programs onto it, so I don't really want to break that. I don't know if you can, but I'm also thinking I might be out of more. I mean, the problem is I keep, you know, you don't want to add so much stuff, you know, you don't want to make things so complicated. But I'm using, I could definitely share the I/O expander with really slow moving on-off signals, because the only thing on the I2C line is the DAC, the slow DAC, and I'm only going to be switching these things on and off like once. But these I could put that's what I found. I've got 1, 2, 3, 4 things that don't really need switching that often. Like they're just sort of like initialization switches. Wait, have I worked out that I have gate out? Got 4 CV ins, 4 gate ins. Two gate outs. Oh, it's fine. And then my 4 analog outs come out of that, and my other analog outs come out of that one. Yeah, they've. Oh, sorry, you can't see. I was in a different view. I was looking at this. These are pins that I've pulled out that are quite slow, because these. Yeah, sorry, I fixed it. Sorry. These are the 4 pins that I've just pulled out from to free up space, and one is for meeting the DAC. It's kind of useless, but I thought it might be a nice feature to keep. And then there's these 2 more for the ADC for putting into different format modes. I only have that because I'm like, well, maybe I only have that because like maybe I just want to experiment with the different modes. I don't even know if this is going to work very well, the ADC. And then this lets you reset the USB host device. So there, I've opened up loads of space. So I've definitely got space for those. Other worry is I'm not sure if I've got enough PIOs to do all these things at once. But how much is the MCP Oh, it's expensive. £1.50. What I normally do is I go by the most popular, just to see what there is there. That was £1, but what is that? No, that's like a pulse width. Oh, no, that's fine. The only thing is my... Something I don't know is, can you make I squared C go at 2 different speeds? If I only talk to one thing once and just leave it, I might just Google that. Multiple speeds on one line. Is mixed frequency possible? It's not a good idea. TP. Because I think the 4728 can go like megahertz. Yeah, it can go 3.4 megabits a second. It'd be good if the I/O expander was matched to that. Oh, there we go. Nothing left. £3. I could just put it on the Stemma QT one. Yeah, why not? Probably don't want to be busying up my ADC line anyway. DAC line, I mean. So what's the most popular, well, the most in stock? This one's 50p. This one's also 50p. Texas Instruments one. Quite big though. It can provide, it only goes 400 kilohertz, and it can provide 16 IOs. These are level shifters. Do they not have one just for expanders? That one must be cheap. PCF, and it's quite small. Oh, there it is. Was it the PCF? Oh no, PCF 8574. Oh, £1.60. They've used it before. Is it obsolete? PCA 9548. Oh no, that's something else. This looks like quite a nice size. SO, still quite big. Yeah, I could use a shift register. And it's really slow. Yeah, I could just use a 595. But I'm using on my SPI, and that would use, I would need a clock. What would I need? I need a clock and a data pin, so that's 2 pins, and I'm just trying to use the existing I2C buses that are already connected and using pins. I'm tempted to use this 50p one, but it's quite big. And I don't want to use anything that's too obscure. I might just go for it, and then like later on I might delete it and be like, whatever. I could, you know, see these things, I could just make them, well, the power one, you know what, might actually, no, thinking about it, that one's important, because it's quite good for resetting devices, but these could just be solder jumpers. I don't need, or jumpers, I don't need them to actually be written in software. Where are they from? 2's from over here. I don't need to mute my DAC, so I could delete the mute one. I'll leave it there just for memory's sake, but I'll put no connection on it. But these I'll just turn into jumpers. Probably solder jumpers. Oh, I'm doing that again, aren't I? Sorry. Yeah, sorry, I've moved, I've basically realised that I'd need this power enable one. This power enable one, I need it, but I realised I don't need the mute. I'll leave it there just so I can remember I decided not to use it. Oops. I've put it as not connected, and these are just configuration, like hardware configuration bits, and I'm thinking I will just put them with, let me just go back to this view, I'll just put them with solder jumpers. I'll have them open. I wonder why it's why are they coming in as do not place? Oh, it's excluded from billing it. But we'll complain about that later. Oh, what is it? They're either high or low, aren't they? So I'll have to put resistors in. There. they've got their Schmidt trigger input with internal pull downs, so they're default 0, and I can just pull them up. So all I need to do is just get rid of this junk. Ah. Oops. There you go. I could connect them there, but it'd be too messy. So I'll just make them solder jumpers. They're default 0. I haven't really got into programming this chip, so there's a whole minefield coming. But what I know, just look at the different formats. It'll default to it'll default to slave mode. It'll have to be part of the prototype. I'll have to work that all out. So now I've freed up 2. There was supposed to be 2. Why is there not 2? Chris Johnson's asking, do you know if they're DC coupled? I don't know, so I'm going to test it out this time. I've experimented with the output one, the PCM 5102, and it is DC coupled on the output, definitely. I wrote just a single bit to it, and it came out and it just stayed there. But I don't know about this. So the experiment I'm doing is, I've got these coupling capacitors on the input, but they're actually 0 ohm resistors, and then it might not work because it probably has some kind of bias circuitry inside. So, and it might just end up clipping or doing something weird. I don't know. I don't even know if I scaled it right. I need to go back over that later on. But the weird thing is I thought I just freed up 2 pins and now I can't see them. Oh, I've put them in. And then I've got another spare pin. Yeah, USB host is here. In the Pico, I think USB host is. In fact, I was just going to copy. Well, nah. I was going to copy it from the same location. They have USB host on 32 and 33. Oh, I don't care. It uses the GPIO. It uses the, I think, so talk about USB host in the datasheet. It's not a peripheral. OTP. That's the USB peripheral. The main USB. Oh, host mode. Yeah, but I'm not using it as a host. I'm using the hardware, and you can make a second USB host. Using a PIO, but again, I'm using so many PIOs. I don't know if they're all capable of running at the same time. Because there's going to be a PIO for the I2C, I2S sound, and there's a PIO for the USB host. There might be a PIO needed for the... Well, I think it'll just have to come at a compromise. So, like, if you want to have a fast SD card, you'd be using PIOs for that, but then you might not be able to use a USB host at the same time. I don't know. It's kind of like a... This board is just going to be kind of an experiment to see what's capable, what's possible. It can be reconfigured in different ways. Great. So continue with it. I said I was going to do layout today, but I'm an hour in and I haven't even finished the error checking of the schematic. Oh, there's another ground A. Another one there. Don't know why that one didn't. Some pins not connected yet, that's fine. Oh, another analog ground. Oh, what? I'm finding them everywhere. It's only showing me one at a time. I tried to do this, look. Change symbol. Change any symbol that matching the value ground A, okay. And then change it to that. Change. Oh, there we go, that's the last one. I'll put this in to stop it complaining. What was the... And then the last check was like MCU gate out 1. Yeah, that's fine. Yay, no more errors. Now there's warnings. Grid problems. This is because I've got random... I've mashed it together. It's done in various historical parts of... yeah. That's good. And now another thing I want to do is... The weird thing is I thought I routed this, but I didn't. Also, what I've done is my stack. I think I want to have ground in the middle and on the bottom. So I have 2 signal layers. And I could probably route my more delicate stuff on this layer. More analog stuff and go on the orange layer. And the digital stuff and go on the top. Although no, wait. Maybe my digital stuff will go on the inside. Because basically I need to get... Where are they gone? Should be here. The first thing I want to do... Oh, is it over here now? Is the USB lines. Oh yeah. Yeah, there they are. But they go onto the bottom layer. Now the annoying thing is that I did want to use the... I just wanted to see if this tool would work, but it doesn't work. Oh, it does work now. See, the problem is, I think it should just go straight down. Oh, it's because I moved it. Here they are. Right, dim. Really, they should go to, just coincidentally, 11 and 12. All of my USB host pins are close to that as well. They're at 8 and 9. So these come from 66 and 67, and 8 and 9 must be over here. It'd be good if they were like... No, but they're all that's all the important memory stuff. It'd be good if it was here, 78 and 79. Oh, and that's not being used. Oh, I haven't updated it, that's why. Brilliant. I'm going to pull out my host ones. I'm going to move these down. Oh, that's not updated. Oh, I was going to say, yeah, yes it is. Oh. I moved it too far and I made it 7980. We want to be as close as possible. The good thing about all these pins is they are not using any specific peripherals that are mapped to certain pins. They're just general purpose pins. It's going to be slow. It's going to be slow. Don't want that. Can I use that tool again? No. It's because I've named it something out of the convention. I can't be bothered to fix that, so I'm just going to do a via, huge via. Ah. I want to have pretty small vias. Vias. I'll do it for 2 layers, even though it's multi-layer, but the hole should be 0.15. Let's do 0.16. The outer diameter 0.26. It's good to be slightly above because sometimes there's like metric. There's metric conversion problem, metric to imperial. Whoa, those are tiny. Minimum via size, 1 layer. Oh yeah, wait a minute. Preferred min hole size 0.2. They can sometimes get you with little extra charges. Preferred min hole size is 0.6, 0.2. Oh, I'm doing it wide bigger. Preferred minimum hole size 0.2. And it should be 0.15 bigger than the hole size, so that's 0.35. Is that right? 2, 3, yeah. This doesn't look right. Is that right? It looks so bizarre now that they've changed the where are we routing? We're routing on the inner layer. It'd be great if we could just go straight down as well, but we might just go like that. USB host is only ever going to be something like a MIDI controller. I mean, it'd be cool to try like mass storage or something, I don't know. It'd be cool, so I'd like my USBs to be at 12, 11, 10 and 9. What do? Do I just flip everything around? That's 4 pins, right? Got 1, 2, 3, 4. What is 4 pins? Okay, 1. Good if the audio in and out were next to each other. Are these a 4? I'm basically choosing I want it to be a 12, 11, 10, 9. It'd be good if there weren't any analog signals next to this stuff. So keep the audio next to each other. I guess the gates could go next to it, doesn't really matter, does it? They need to be there. Four CVs go here, I guess. This is CV or gate in. Bit strange. Bit weird having USB in between all of that. Now I have to remember. No, now I have to rearrange this. I've got gate in 1, gate in 2, and these go out over to here. These come in. So it's, no, that's wrong. USB DM DP, USB host, these are the wrong way around. And then CV in 1 and 2 go. And then I've got this. I want the audio. I'm putting the audios next to each other. Don't know why. No, that's not it. I need gate out 1. It's called CV. No, that's the wrong one. CV in 1, 2, jack. Gate in 1, 2. Where's gate out? Switch run. switch user 1, switch user 2, display, SEL, yeah. Encoder 1, encoder 2, audio 1, audio 2, audio out 1, audio out 2, CV in 1, CV in 1, CV 2, CV in 2, gate in 1, gate in 1, gate in 2, gate in 2, USB DB host, USB DB host, USB DM, DM, DN, DM, DP, DP. Why are these different? CV gate. Oh. CV gate and 3, 4. But they're not. Where's gate out? Why is these called micro? Ah, they're wrong. Found a mistake. And that should correspond to the gate out here. Ah, that's why they're mislabeled here. And they're called in. Right. Let me just double check that in ERC. Yeah, there's a new error. Not connected to anything. Gate out to jack. Oh yeah, I labelled it the same twice. Now, they're mixed up. So I need to swap round DP and DN on this, on both sides. Okay, and they're not swapped round here. I need to work this out properly, but huh? Oh, it needs a via, doesn't it? Sorry. Not really perfect putting them through vias, but again, especially the USB host, it's not exactly high speed USB. I also need to think about these trace widths and stuff like that, but I need to work it out. Right, I said I was going to be routing all of this, but I don't think I am. I need to look at all the op amps. That needs to go through the connector. Luckily I've got a spare. Why can't I select that? What do I do? Oops. Sorry, I'm being very quiet. I was just double checking my stream. So this is all just going to be on the other board. I can move. I went through this on the last video, it's quite cool. Well, it's just lets you turn the power bus off to the USB host. Needs 2 transistors because it's so you can do high side switching. I don't know how useful it is to turn on and off the power supply to the host, but it seems a good idea to me. And now what am I doing? My idea now is, I think what I'll do is I'll just go over the power section, and then I think I might call it a day. We'll work more tomorrow on the layout of the chips. So the power section, I've got the connector coming in here, there. What's this little capacitor? Okay, that's just lost. It belongs to U20, whoever that is. Oh yeah. I'll stick it near there. Got the power coming in. I can route this probably. I'll route this. Make a nice chunky 0.6. On the top layer. So it goes into the MOSFET. I might use nice. No, I won't. Goes to ground through a wire. 12 volts. I'll do it with skinny tracks, and then later on I'll think about how it's laid out a little bit better. Goes up into, because I might put some ground planes here. Pin 5 That's enable. It's actually pin 3, that's the power. I think that's great. Really I need to think about how to get pin 3 the other way round. And this is all in, isn't it? Yeah. See, that is all the this funny switching buck power supply I've put in. I decided to do this just to learn how to do it. I know it's a bit... switching supplies are tricky. I have to go through all the equations. I just copied this from the this Adafruit product. It's quite energy efficient. And then I have this regulator that's pretty much powering this chip and these two guys, I think. The DAC and the ADC. Audio DAC and audio ADC. I've got them stacked here. Not sure if that's great. They're on the right hand side, and on my connector, brilliant, they're on the right hand side too. So it's great if they're there. And then there's these two op amps, which are my U8 and U17, which must be these guys. Yeah, U8, U17, which are my CV out thingy-madoodles. Where are they on the connector? Ah, put them at the other end. Yeah. So I should move those over to this side. And what have I got here? I've got my CV ins here. I might just grab that all as once. There's a power supply for it, and there's all these parts, but not those parts. Deselect, control. Wait. Not doing too well here. Wish there was a tool that let you select with a lasso, that'd be good. I feel like I've unselected and reselected about 50 pin. Ah! Don't want that. Don't want that. Don't want that. Don't want that. Don't want you. Don't want you. They should all be highlighted here. Also want these. These are the decoupling capacitors. Oh, what's this one? Oh yeah, what's the selection filter? There is a selection filter for the scan. I don't know what I'm selecting here. What's this? What's this one? I can't see what that is. C6. Where's C6? This is KiCad 9. I'm just going to move it all. Don't want to wreck that layout. But I probably, in my connector, I've got on this end gate in, CV in, audio out. So gate in to 1, 2, CV in, 1, 2. Kind of random. Wait, what is gate in? Oh, gate in 1, 2. I think I'd want gate in 1, 2 and CV in 3, 4 instead. So instead of CV in 1, 2, I want CV gate in, and I'll put CV in down here. I'm basically moving things around just to make them more convenient on the connector. Because now that means these comparators can be next to each other on the right hand side, so this one and this one. Oh, not on there. One's in already, and there's a new one. There's a new comparator in town. They should be on this side. Probably want this stuff. To move up. I want my comparators to move down and this way a little bit. The other one's here, right? It just has a voltage divider with it. I can pack and move that. Just put on pin 6. Doesn't really matter though. Just whack things in randomly. And this one should have these guys. Sticking them in randomly. But what was I was supposed to be doing power. I checked over the stuff associated with the Raspberry Pi is all done already because I did it through the design guide. This power is all done. If I select it all, you can see it's roughly in this area, needs neatening up. Oh, but the rest of the power would be associated with whatever they are, so this lot of stuff, pack and move these guys, should be with these somehow. Where are their power pins? That one's on the right and that one's on the left. Great. Maybe that one should go upside down. I'm using these giant capacitors. Power's over here. It takes 12 volts in. It's quite a big jump. It'd be good if it's here, I guess. And then it's got input capacitor, which is pin 1. So it goes up there. Got an output. I don't think that is necessary. Delete that. Deleting parts so I don't have to deal with them. And then there's one here. That goes on pin 4. What next? Looking like a lot of components are on board now. What are all these? Can't even see where those are. That is for U21, which is the comparator. Show it there. Move that up. This is... Oh, these go on the jacks. I'll leave them there. Pull downs. Oh yeah, these were new ones for the stemma QT connector. Pull ups for the I2C. Yeah, they go here. You know what I'm probably going to do is get rid of all the reference designators. This one, oh, goes on the ADC, should be near pin 59. Let's get rid of that. Getting there, getting there. Don't know what these are. Oh, ferrite beads. I haven't really decided what to do yet. I need to think about that business. What are these? These are input op amps. Yeah, these ones should go near this one and all its associated components. Should go near. Need to go near the pack and move. Nope, won't let me. Leaving the ferrite beads for now. This goes near 6. This one goes between 6 and 7. Oh, and there's this guy, a tiny little capacitor parallel. What are these ones? Oh, that's the second one. Yeah, it's two op amps. One goes between 1 and 2. And then it should have a little mini one, which goes in parallel with that. Let's hide that. This is for the ADC, which is the much more, is it the more compact one? That one? Yeah. What are these? I might need to shrink these down. And 4. These are a bit over the top. Getting tired. Just stick these on top for now. So they come up with a decision what to do with them. This eventually, the outputs go to this business. C9 and C10. These are the low pass filters for C9 and C10. There they are. I don't know why they're so massive. I need to sort that out later. All that stuff that needs to come down here now. And this is for U6, which was the one we just moved. This belongs to U6. Probably should make all my decoupling capacitors smaller. Screw it, I'm going to do it now. Thing is, I've already got them as 04. Already got. I might as well just make them all the same. Where are they? These, all of these. They're grouped here, but they're actually different packages. I have to do it in here. Can I filter by? No, that's for the libraries. I find it weird that you can't sort by value here. All of these, they're all big 0805s, but I want to make them I like making them big because I know that they don't suffer from, they suffer from derating at DC. So if you make them big ones, they are less likely to lose their value. But they all need to be 0402, basically. Yeah, it's good to make the big ones, like the 10 microfarad ones. But screw it, let's just make these. For some reason I don't have enough 402 footprint, so I need to make one of those. But for now I'll just use the standard. So now observe, loads of components are going to shrink, hopefully. Yep, there you go. I haven't messed up these, no. Now I'm just gonna, I think what I'll also do is terrible, but I will probably get rid of all the reference designators. Make them all invisible. I might bring them back in later when I can see space. Wait, why are these still massive? Oh yeah, because they're big values. This is meant to be pin 1. Guess I could put it like that. This little tiny 100N one. I don't. It's kind of awkward, isn't it? I wonder whether there's a more sensible solution to this. This is for pin 3. So they're still massive. And annoyingly, they're all on the same side. Pin 4. Anyway, I'm going to ignore that for now. What's this? Oh, this is a connector. It's not quite right though. I need to rethink that. I'll put it over here. That leaves this one is meant for U6, which is this. Oh, that's U19, U21, is it this one? U6. That's for the 12 volts. Now there should be some space here. This one that goes between 1 and 2. What are these capacitors? No, these are resistors. Should I be using 0402 resistors? Maybe. Resistors. In basic parts, I can get 0402s, I think. Okay. What values? 1 ohm. Can I get 100k? Yeah, seems fine. But what tolerance? Yeah, I don't think you can get tight tolerance. Think about that later. They're generally quarter 60 milliwatts. Don't think that's a problem. Should I change my resistors to 0402? Yeah. Just change every single one. D. Currently a mix of a load of different things anyway. Look how much space there is now. Hey, what's the... Oh, so I have my own 402 capacitor, but not resistor. I just need to change it. I can just copy that. Good footprint editor. Oh god. I hate it when the you do something and the processor starts, your computer starts buzzing. Okay. We want C, and we just copy that. Or we just want to duplicate it, I mean. And we're going to call it R. I just like having the silk screen around the resistor so you can see, because when you get loads of them together it just looks like a mess of squares. I have enough space in this board to have white squares around them all. There you go. Why are these not got white squares? Oh, there's a few capacitors that not got the white squares. Oh, that'd be hard to select though. Well, every time there's a capacitor, 0402. Well, that's what I'm doing anyway. I am a little bit worried about derating, making these capacitors too small and they get derated at DC when they're biased, you know, when they're on a DC rail. Please hope that works. Please that work. There we go. I have to get rid of all the designators again. Okay, loads of space. I just do think these capacitors should be bigger. Because if you look at don't really get these charts with every single capacitor, but if you look at, oh, what was that thing? Cap. No, not cap sense. Cap. Oh, there's a place where you could see. This is a capacitor. An 0805 one is this. Is this is this one at the bottom here? And see how it's 1 farad, but it doesn't drop that much. I need it for 100M though. Oh, it was Murata. Was it Murata? I'll think about this later. I just do think they should be bigger, that's all. This needs to go between 1 and 2. So now they're like almost the same size. This one needs to go to 2. Right. This one needs to go to 2 as well. This one needs to go to between 1 and 2. Again, what? Oh yeah, because that's the capacitor. That's. And we could just do this. Let's just do that. These are going to be between 1 and 2. So I'll put. These are going to be. These come in. Oh. Oh, why is it doing that? These come into 2, so we'll do them just below 2, like that. And these are between 1 and 2, so I'll do that. I might move them slightly back. What's this one? Now that's our decoupling cap. Put it as close as I can. Then this is the same business. This one goes into 6. There should be a bias. One also wants to go into 6. And this one is between 6 and 7. Where's this one? All the way over here. This one should be like that. These are 6 and 7, but these just want to be 6. So I'll put these up here. These just want 6. They just want 6. All they can think about is 6. Follow the same with this one. These one want 2. This one wants. This is the 1 and 2. This one just wants 2. Where's that's the decoupling cap. That's for something else. Where's this? Where's this one? All the way down here. Go with that. Where's its decoupling cap? It's here. Should go here. And move the whole lot down. This one wants 6. This one wants 6. Everyone just wants 6. Oh, that's for something else. Oh no, wait, that one wants. That one goes between 6 and 7. This one's. Oh, it's down here. This one. There. See, there's 2 identical parts. And they fit in nicely like that. Now I need to. Now these are for CV in 3 and 4, which should be. No, that's CV out. Wait, where's CV in 3 and 4? CV in 1, 2. Oh no. Where is it? Oh, they're there. They're right at 1 over here. Great. I might just take that out then. I'll keep that in a nice little package though. And then I've got this. Which is, these are CV outs. They want to go on the left. So I'll just sort them out. U8. I might just keep these together. Put the designators back on. Just put it in the middle. Spread them out a bit. Oh, that's something completely different. Oh yes, it's only 2 op amps chips. So that's U8's positive one, U8's negative one goes here. U17's decoupling cap goes here. what's this one? Oh. That belongs up here. Belongs up here. Oh, you have this stuff. That's the power. And then we need to just arrange the capacitors. This one connects to 2 mainly. Of U8. So does this one. This is really boring. So there's this one. And I want the capacitor, it's probably flown off somewhere. And this needs to go between 1 and 2. Probably even just nah. I could do that. Wait, why does that one want to go to 1? Where's this one? This one wants to be here. These guys can go there. This one wants to be there. Don't know why I did it like that, I just did. I just need to copy it again. This one goes. Oh yeah, this one goes at the top. We need the one that goes in between. Oh, it's this one. It goes between this one. Goes there. Oh yeah. Oh, I've started on a different one. One goes there. That one goes there. This one goes there. This one's probably the other one. Might need to stop in a minute. I think when I've done this little bit, I will stop. This goes here. This belongs. This is the one that goes at the top. Is it? Yes. Put the other way around. Goes at the top. This one wants to connect to it too. Then everything else comes in. I'll have to get the spacing fixed afterwards. And that one. Where does this go? It goes there. I need the one that goes there. Goes at the top. This one goes next to it. This one goes here. It goes here. Yeah. That's all of them laid out together. And then this sort of needs to come in, but it goes to those resistors, and the 4 ABCD is like that. I wonder if it would be best to do that. No, there's two nuts. But I'll leave a bit of space so they can get around. And then I have power supply, this little tiny mini one for the power supply, chip, this pin 4. Don't know if that's the best way around. Now that means that can fit down here. Because that becomes CV out. It has 4 ferrite, it has all these ferrite beads. Need to read up a bit more on EMC. I'd really like to do EMC testing, pre-testing, you know, learn a bit about all sort of product testing and stuff. Once you can get ferrite bead arrays. The idea is that I'm filtering the lines before it goes onto the ribbon cable. I don't know if that's the right thing to do. They're all in the wrong order. That goes there. Now, I've got all those. What are these things that go straight out? Oh, it's my display. I wonder if my display wants to be more like near the USB stuff. Yeah, it's all done here. Anyway, as you can see, I'm sort of starting to chunk things up into little circuit modules. So there's modules for all these, there's op amps for these, got the op amps for the analog outputs, and I've chunked together, modularized together all the DACs, the audio DACs. Yeah, I think that's enough for now. Getting tired. But join me tomorrow. See, I'm starting to get a bit glazed. Join me tomorrow, and I'll do more of this, basically. More boring stuff. Thanks for watching, and thanks for all the questions. It does help. Yeah, I'm sure I'm going to be going back and forth and changing things a million times as it develops. I really need to know. I don't know how I'm going to do the SD card, for example. I just have no idea. I might just give in and use the standard SD vertical, the one that everyone uses. I just want to make it as... Thing is, the vertical SD card's not available on the JLC library, so I want to try and avoid it. Anyway, thanks very much for watching.